scalar versus, what did I say here? A vector. Scalar is just a number. Vector is a number and a direction, of course. Or, of course, instead of saying numbers, we should probably talk about magnitudes, yes. Okay, magnitude is how much. Okay. Then we got into, like, here's some examples of vectors, of course. Not only that, not only a quantity or a magnitude, but a direction. Okay. A reminder that distance is like the total that I would travel. So how far do I go? Okay. I could measure that on my Apple Watch kind of thing. Displacement only cares about where you start to where you end up. Okay. So again, with our track thing there, out at HTA track, if you're walking around the track, your distance is going to increase as you keep going around and around. But it depends where you stop, that is your displacement. So if you get back to the start-finish line where you started, you haven't gone anywhere. You're still in the same position that you started in, okay? Even though you did all that exercise, okay? So again, displacement, and another way to say that, of course, we talked about yesterday was it's a straight line between where you started and where you finished, okay? So from A to B here kind of thing, okay? We looked at some examples yesterday, okay, about going east and west and north and south and all that stuff. And then we're going to get to this right here. Now, now, today we're going to talk a little bit about, I'm just going to scooch this down here a bit. Well, maybe I'm not actually. But in this case here, I'm just going to scooch this down while we can take a look at this. You're going to notice that this graph is slightly different than the other ones we've talked about. This one says position versus time. So of course, time is on the x-axis. Position is going to be on the y-axis, and it is, of course, for a runner. Okay. Now, I'm just going to scooch this back up here a little bit now, just because I don't want to get that too confusing there. Okay. So, in fact, I'm going to do this right here. So now we have a position versus time graph. Now, you might say, okay, what does this mean now? Well, you look over here and it says position, and it also gives you, of course, the units, which it has to, because that's how we label things, just like time is in seconds here. We label the axes, and that's all good. But we call this a position versus time graph, and we deal with meters. And you'll also notice it says right here, and I know it's a little tricky to see, but you maybe can see on your notes a little better at home. That says east, okay? Now, the first question you should be asking yourself is, well, why does it say that? Why does it say position? So this isn't a distance versus time graph, okay? This isn't a distance, because distance only has a magnitude, okay? This is actually another way to say this, position versus time, would be to call it a displacement. Displacement versus time graph. All right? So we have to talk about like position or a direction as well. Okay? So let's think about this for a second. And the second thing I'd say is, not only do I notice that, but I also notice that my graph looks a little bit different than normal. Notice most of the graphs we've done so far do this, right? They kind of do this. And we'd have an x and y axis, and we'd talk about this is how far, this is the distance I've gone, yada, 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 and all this stuff. We talk about speed and so on and so on, okay? But notice this graph actually goes below the x-axis. It actually has a -1 down here and a -2 and a -3. And when I see that, right away I think, okay, this is not a normal, simple XY graph kind of thing. Something else is going on here. Obviously, it has to do with this position thing that we're talking about. Okay? So, the first question here is going to say this. Okay? It says, determine the displacement. So notice, displacement, we need to include a direction of the runner from 0 to 2 seconds. So basically they're saying, okay, if I start at 0 and I go to 2 here, what is the position of the runner at this current time from 0 to 2 seconds? What is the position, somebody? Where is the runner now?
4 meters east.
That's right. So the runner is currently at 4 meters, and they headed in the east direction. That's where they are from where they started. Here's where I started. Okay. By the way, if we were in the classroom right now, 4 meters east would be me heading towards the windows, out towards the field there. Okay, that would be 4 meters in the east direction. So I look that way and I say, okay, I'm going to go 4 meters in the east direction. So I start walking. And of course, a meter, by the way, this example is pretty not very typical, because a meter stick, I don't know if you can see me on the video there, in the other feed there or not, and if you can't, don't worry about it, but this is a meter stick right here, okay? And I would only go 4 meters in that direction, so I'd probably get to roughly the wall, okay? If I was standing in the middle of the classroom, I'd probably get to the wall with the windows kind of over by my desk there, kind of thing, okay? That's as far as I would get. So I walk 4 meters in that direction. That's what this implies right here, okay? That's where the runner is right now. And that's where he is. Now, the second part of this question is going to be this, okay? What happens from 2 to 8 seconds here? So what happens from here to here? Now, I want you to think about this logically, okay? You currently are over by the wall, by the windows, looking out into the field there, okay? So now you've walked over that way. You're in the middle of the classroom. You walked over to the wall with the windows by my desk there. Straight line, 4 meters. Okay. What happens in this green section here? Who can tell me?
He moves west.
That's correct. Okay. Look, if he continued to move east, okay. Oops, sorry. Wrong spot there. My bad. If he continued to move in the same direction, wouldn't the graph keep going like this, right? So he's at the wall right now, and if you wanted to continue going, you'd have to go through the window, I guess, and keep walking out towards the field. Well, look, obviously something's happening here, because we are not going in this direction anymore. In other words, we have kind of got to 4 meters away from my reference point. Now he's going to turn around, and he's actually going to head in the west direction. And he's going to do that for this entire part right here until he gets to here, okay? Now, remember, this is my reference point. This is where I started right here. Look what happens. He goes 4 meters east. He turns around and comes back 4 meters west. He's back at the reference point that he originally started at, okay, at that point right there. So I would start in the middle of the classroom. I'd walk towards my desk for 4 meters. I'd turn around. I'd head towards the mountains for 4 meters. I'm back to exactly where I was before. I'm going to keep going for another 2 meters. Look, 1, 2 meters. So I'm going to go past there now. I'm going to end up kind of over where, probably about halfway between, who sits in this row here? George would sit in this row. Rebecca would be over here too, kind of thing. Morgan, okay. I'm standing in front of their row right now, okay, and because I've gone 2 meters past where I started from. So if this was in the middle of the classroom, this would be the wall with the windows, okay, and now I'm back to the middle here, and now I'm over by kind of Morgan's desk there, kind of thing, okay. Now, that's the second part of this question. By the way, how far was that? The answer is what? 1 meter, 2 meters, 3 meters, 4 meters, 5 meters, 6 meters in the west direction. Okay? 4 to a -2, that is 6 meters in the west direction. And that would be the second part of this question right here, from 2 to 8. So you guys can go ahead and put that in there. 6 meters in the west direction. That was this section right here, 6 meters in the west direction. Okay? Is everyone okay with that? Does anybody have any questions about that? Okay. Now, okay, and we're going to come back to this in a second here, I guess, but now he's going to start what? He gets to there, he gets to about Morgan's desk roughly, or this runner, and now they're going to start going back to the east section here. So they're going to start heading back out east, okay? They're going to stay there for a little bit of time, and then they're going to go back to the west direction here, okay? We'll talk about that as we go here. Now, it says this, okay, and this is what I need you to understand here again. I know there's up and downs here, and there's stuff where it's staying the same. Okay, I don't think I can do this fast enough here. But now it says, what is the displacement? What is the total displacement of this runner? And George cannot answer this one. 0. Okay, so now we have 0 meters. Okay, that is the total displacement. All right. Is that good, everybody?
Yes.
Okay. All right. So, why is it 0 meters? Well, again, starts here. Let's say this is the middle of the room here. Goes to the windows. Goes back to the middle of the room. Over to Morgan's desk here. Back to the middle. Okay. Back, not quite. I would say this is probably row 2 here. So this would be Sophia and Juliana and Chloe and Riley there, kind of back to about here. Stays there for a bit. So has a chat with Sophia there. Then, okay, goes back to the middle of the room. I started in the middle of the room. I ended in the middle of the room because this is the middle of the room, if you want to think of it that way, or that is my reference points. Those are my 0 meters there, okay? So that is the displacement that has taken place here. So the answer is 0 meters, okay? 0 meters. We don't need a direction because he hasn't, this runner technically did not, hasn't moved from his original spot. I mean, yes, he did move, but he came back to the same spot, so therefore he's in the same spot that he started. So he is, where did he start? He started at 0 meters. Where did he end up? He ended up at 0 meters. He hasn't gone anywhere technically as far as displacement is concerned, a straight line between the starting point and the final point. Okay? Is that good, everybody? So the displacement is 0. Okay? Now you might say, well, it looks to me like he's gone places because look, I got this graph that does all this stuff here. Well, yes, but remember, that graph is nothing more than, I'm just going to, we can erase that too, I guess. This graph is nothing more than this, right? Look, this is 4 meters going in this direction here, so there's 4 meters. This, technically, is what, 6 meters in the south direction. So that's that, okay? This right here would bring me back to here, and then another 2 meters, so up to here, okay? Then he stays there for a period of time, then goes back to basically here, okay? That's really what this graph is. The problem, the reason it's kind of looks like this is because we have to talk about the time factor here. The time is stretching this out. So instead of just going up, we are going up, stays, down, okay? And this is spread over this time here, and that's why the graph looks like it does, okay? Because we're counting the seconds here as we go, okay? So the displacement again would be 0 meters, and that's what's happening with this graph. Now, the next question they're going to ask you is this here, of course, all right? What is the total distance the runner ran? Oops, don't look. So again, if we want to talk about the total distance, now this actually matters. So again, if I had my Apple Watch and I turned my workout on or whatever kind of thing, or if I have a GPS tracker, it would say, what? I went 4 meters this way. It doesn't matter the distance now, or it doesn't matter the direction, because this is distance, yes? So distance has nothing to do with direction, just the magnitude. Went 4 meters that way, went what? 6 meters that way, okay, from a 4 down to a -2, so that's 6. I went what? 4 meters this way, that's 0, didn't go anywhere there. And then I went backwards to, well, not backwards, but I went in the opposite direction 2 meters. So if I add all those up, 4, 6, okay, and you might want to write this down, 4 plus 6 plus 4 plus 0 plus 2 meters, and I believe that gives us what, 16 meters. Okay, and that would be the distance that he's traveled in this case. Okay, is that good? Is there any questions on that? Okay. And lastly here, the last part of this question is describe the motion of the runner. Okay, so quite often we're going to have to describe what's happening with this graph. And again, you know, this is where these units are very, very important here. Okay, what is it? What is this graph of? And what are my units and which direction am I going? Okay, so we can talk about this section right here, and then obviously something's happening here that we've already talked about. So you could say from, you know, 0 to 2 seconds. Okay, runner moves in moves 4 meters in the east direction. Okay, that'll take you up to there. From 2 to 6, well, 2 to actually what, 8, I guess. Okay, from 2 to 8 seconds. I mean, you could break it up more if you wanted to. You could talk about, you know, actually, you could talk about this section here where he gets back to where he started from, I guess, if you wanted to. But 2 to 8 seconds, so that includes all this. Runner moves 6 meters in the west direction. Runner moves 6 meters in the west direction. Okay. And then from 8 to 10 here, I guess, 8 to 10 seconds. And again, you could just label these on the graph if you wanted to, A, B, C, D, or something like that. But we're going to go, what, 1, 2, 3, 4 meters. Okay. Runner moves 4 meters in the east direction. 4 meters in the east direction. 1, 2, 3, 4. From what? 10 to 11. 10 to 11 seconds. Okay. Runner. Well, you could say runner, I guess, maybe does not move. Okay. You could say stationary, anything to do that, or you could say he's at rest. He rests there, or whatever kind of thing. From 10 to 11. Okay, that'll take you up to this point right here, kind of thing. And then from 11 to 13, 13 seconds. Okay, runner moves. What is it? How many places do I get? 2 meters, I guess, right? 2 meters in the west direction. Back to, you could even say back to the original starting spot, or back to, well, whatever. Back to the starting spot, basically. Okay? All right. Is there any questions with that, anyone? Yes, no? Questions? Okay. And that's what's happening with that there. Okay. And again, we have to be able to describe these graphs. And when we look at this graph, we have to understand what this graph is, of course, trying to explain to us. So it's interpreting graphs. Okay. And we're going to have more graphs as well down the road here. So it's really important. The first thing when you get a graph, you should look at this and you should look at this. Okay. And that's going to tell you a lot about that graph and what's happening. Then I would take a look for, does this graph look a little different than some of the graphs? If it's only this section here, okay, that's kind of a more typical graph that I'm used to. If there's a bottom part to this graph, well, that's obviously telling me something as well there. And that's obviously, look, they wouldn't include that unless you had to, okay? So keep that in mind. If they include a -1, -2, -3 kind of thing like that, it's probably because it means something and you're going to have to use that to explain something here, okay? All right, so today here, you guys had questions 1, 2, 4, and 5 last day. And then today, we did skip over one here, which was question number 3. So in your homework for that lesson 5 there, which is what lesson we're on here, lesson 5, in your homework there, we skipped over 3. Now the answers are there, and I get that, but you should really take a look at that question number 3 there. That's going to be your homework for the weekend. Not too much this weekend here for you. But